You know, have you ever just stopped and wondered why some things just work? Your car starts every morning, your phone doesn't crash. Well, a lot of the time, that's not luck. It's because of this incredible, almost invisible process that's designed to stop disasters before they even start. And today, we're pulling back the curtain on that proactive blueprint. We have all seen the headlines, right? Some brand new gadget has a major bug, or an entire car model gets recalled for a really dangerous defect. These things feel like they come out of nowhere, but the truth is, the problems were usually there all along, just hiding, planted way back in the design and manufacturing process. And it's almost never just one big mistake. It's usually this chain reaction, a series of small, overlooked issues that cascade. It's like a domino effect that, honestly, could have been predicted and, more importantly, could have been stopped. And that domino effect? Oh, it can be absolutely brutal. We're not talking about small bumps in the road here. A single product failure can trigger these massive, expensive recalls. It can cost a company millions, even billions, and completely shatter customer trust that took decades to build. And in the worst-case scenarios, it can create serious, life-threatening safety hazards. So, what's the secret? How do the best companies out there dodge these bullets? Well, they don't sit around and wait for things to break. They have a proactive solution, a way of methodically hunting down problems before they ever see the light of day. And that solution has a name: Failure Mode and Effects Analysis, or FMEA for short. The best way to think about it is like structured pessimism. It's literally a formal process where teams get in a room and ask, all right, what are all the ways this thing could possibly go wrong? The goal isn't to be negative. It's to get ahead of failure so you can prevent it. And this is so important to get. FMEA isn't some magic wand you wave. It's a tool that works best when you have this culture of collaboration. It takes the expertise of everyone, engineers, designers, manufacturing folks, and focuses all that brainpower on potential risks. It makes smart people even smarter by working together. Now, FMEA isn't just one thing. You can think of it as being split into two major categories, and each one looks for failures through a totally different lens. One looks at the product itself, and the other looks at how that product is actually put together. So let's break this down, because it's pretty straightforward. On one side, you have Design FMEA, or DFMEA. This is all about the blueprint. The team is asking, could the material we chose for this phone case crack if you drop it? Then you have Process FMEA, or PFMEA. That's all about the assembly line. It's asking, could a robot arm be putting in a screw too tightly? So one is about the what, and the other is about the how. Okay, so your team has brainstormed this huge list of potential failures. Now what? You can't fix everything at once. How do you know where to even start? Well, that's where the FMEA playbook comes in. It has a system for scoring and prioritizing every single risk. The process itself is really logical. First, you brainstorm every possible way something could fail. Then, for each of those potential failures, you figure out what the consequences would be and what might cause it. After that comes the really crucial step, scoring the risk so you know what to focus on. And finally, you create a real action plan to tackle the big stuff. And that scoring step, that's really the analytical heart of the whole FMEA process. It's what brings some real objectivity to the table, and it does it by looking at three simple but really powerful factors. Okay, first up is severity. Simple question: if this failure happens, how bad is it? A squeaky hinge on a glove box is, low severity. A total brake failure, that's maximum severity. Second is occurrence. How likely is this to actually happen? Are we talking a 1 in a million shot or a known common problem? And third, detection. How easy is it for us to catch this problem before it gets to the customer? A scratch on the paint is easy to see. A microscopic crack deep inside an engine is not. Then you take those three scores, severity, occurrence, and detection, and you multiply them together. That gives you one single number, the risk priority number, or RPN. And a high RPN basically acts like a giant red flag. It points right at the most dangerous potential failures and tells the team, hey, look here, this is where you need to focus your energy first. So, after all this work, all this structured worrying, what's the real payoff? Why go through all the trouble? The answer is incredibly simple, and it all comes down to time and money. The core idea here is so powerful.
The sooner you find a problem, the ridiculously cheaper it is to fix. A small change to a digital blueprint in the design phase, that might cost next to nothing. But finding that exact same problem after a million products have been sold, we're talking exponentially more. It could be a company killer.
And look, finding problems early isn't just about saving money. It gives you options. You have so many more choices for how to fix the root cause, the solutions are way cheaper to implement, and you can actually test to make sure your fix works. It's all about being in control instead of being in crisis mode. So, when you boil it all down, here's what FMEA really is. It's more than just a document on a server somewhere. It's a disciplined, proactive way of thinking. It's about taking the terrifying unknown of a potential disaster and turning it into a known, prioritized, and totally manageable risk. And that kind of leaves you with a final thought, doesn't it? The most successful FMEAs, the best ones, are the ones you never ever hear about. They are the silent guardians, preventing failures day in and day out. So the next time you pick up a product that works flawlessly, just think, how many potential disasters were quietly stopped in their tracks by this exact process?